Today we are going to do the Advent of Code. As many of you probably know, the Advent of Code is a series of puzzles that are published day by day throughout December by Erik Wassel. And I have not yet looked at today's problem. Like today is the 4th of December, so I haven't yet solved that problem. So in deviation from the way that we usually approach the Haskell Unfolder, where we are preparing the topics that we are talking about, I'm going to be totally surprised. So this will be exciting. That also means that I cannot really predict the length of this episode, but I'm looking forward to trying Haskell on this problem.
Yeah, so welcome everybody to the Haskell Unfolder, a YouTube series where we discuss all things Haskell. As always, the show is live streamed. Even though this is a little bit different today, if you have questions about something that we're doing, feel free to leave a question or a comment in the chat, and we'll try it. And if appropriate, we'll try to show them on screen and discuss them. Although, if you have any suggestions or tips, then I won't be showing them because I'm going to let Anders do his thing.
Yeah, as long as you're not spoiling the solution.
Yeah.
And conversely, of course, it means that if you still want to do this, then perhaps you should watch this only later. Like if you still want to do this yourself, right? And haven't already. But yes, okay. So let's have a look at the task. So this is the website of the Advent of Code. I'm going to click on the task for number 4. So these problems, for those of you who haven't done this that often, they always have a similar structure. They start with a little bit of flavor text, and there's usually some sample input. Then there is a bigger puzzle input that you're getting. And one important quirk is that every puzzle actually consists of 2 parts. And there's usually 2 parts that are to be solved given the same input. But the specification otherwise can massively change between those 2 parts. And you can only see the second part once you've solved the first one correctly. So sometimes you're have to think a little bit about ahead, or you're kind of perhaps guided gently into overgeneralizing in the wrong direction, so that your expectations are thwarted afterwards. But okay, so let's see. So I'm going to skip the introduction. Let's see. But okay, so it looks like it starts relatively early. So there's some kind of word search. Okay. So we have to find one word. Xmas. This word search allows words to be horizontal, vertical, diagonal, written backwards, or even overlapping other words. It's a little unusual though. So you don't merely need to find one instance of Xmas, you need to find all of them. Here are a few ways Xmas might appear where irrelevant characters have been replaced with dot. Okay, so we get this grid of letters, and then we have to find all occurrences of this word. Interesting. Okay, so usually, or very often, these Advent of Code programs have or problems have slightly weird input formats. So I had been expecting that we could potentially talk a little bit about megaparsec, which I'm usually using to write the parsers, but here I'm not sure whether I will actually need this, because I mean this grid of letters is very easy to parse even by normal means. Okay, let's also briefly look at just what size our puzzle input actually is like. So okay, so this is the actual puzzle input, and we can see that it basically consists primarily of the letters that make up the word Xmas. Okay, so there will be quite a few occurrences, I guess. Okay. So I guess the biggest question to answer is, how do we actually want to store our data? So we need some sort of coordinates, I guess, in order to access different positions. So the way that I'm thinking about solving the problem right now is potentially just compute all the candidate combinations of coordinates that could be having the word Xmas in it, and then simply check all of them. I'm not sure whether that is too expensive, but it should still be linear in the size of the grid. So I think that should be fine, right? So then the question is, how do you best look up in a data structure? I guess the two possible choices are some kind of array, or what I also often just use is a finite map. In particular, if you have to do some updating, then the choice is clearly a finite map. But here, I'm less convinced. On the other hand, I also don't think that it's really, the lookup speed is really going to be massively difficult. So finite maps are the more natural data structure. So perhaps I'll just stick with that. We'll see. Okay, so let me actually copy the sample input that I have here. Oops. And look at my editor buffer. So I have created a little bit of a skeleton, which is purely based on sort of my general expectations for advent of code problems. So I was expecting, as I said, to have a parser, reading a file name from the command line here. I'm fetching the input, but the input is parsed according to a currently trivial parser. So this is just wrapper code for printing out the parse errors. And then there are usually two parts, which often produce numbers, which are based on this input. So this is my skeleton program. So let's create sample.txt. Copy that here. Let's go back here. So our input in our case is, so that's the, let's say, the process type of input. And let's try with a map. I don't know. So a map of int to char, I guess. And then I need to import data.map. And in order to parse, do I even want to write a parser? I think I don't. I think I'll hand write all this in this case. So let's just get rid of this. So here we still go file path to IO input. I'll read a file using read file. Read file is slightly controversial because it uses so-called lazy IO, but for simple problems such as this, it's really the easiest choice. Then I guess we want to split the input into lines, so we can do that. And we want to somehow map coordinates. Am I too hung up on the coordinates? I'm wondering whether there is an easier way to check the candidates than by coordinates. No, I think I guess we need to kind of figure out how large this is in order to create all the candidates. Can we do this directly within a list? It's a little bit weird if we have to do diagonal access without having so I don't currently see a better way. So let's split this into lines. So that is now a list of strings. And so once I have a list of strings, I can in principle assign these kind of two-dimensional coordinates to it. So I want to get something like position. Basically, I want to get the list from which I can create a map. So I want to create something like pure, sorry, not pure map from list. Right, I want to, I want to create this list of pairs of integers and characters from this list of strings, which is actually a list of characters, right? So I guess I can use a list comprehension here, where I do something like I, J, comma, C, where I get first, I should probably zip the line numbers. Let's start with 0. So let's number the lines by zipping 0 ... with the lines, and then I'm getting I, L out of this. So that's a single line together with a line number. And then I'm going to zip 0 ... with L again to number the columns within that line. And then I'm going to get J, C, which is the actual character that I'm interested in from that. And I think that should give me what I'm looking for. So let me print the input here just for debugging purposes. And let's see if I can just run this and call do4, which is my binary. So I have a Cabal file set up for this that I can call on the sample.txt to get an idea of whether this looks plausible. 00mmsxx. How did the sample file look? Yeah, I think that is plausible. Is that plausible to you as well, Edsco, so far? You're muted. I'm not sure for how long you're already talking. But...
no, just for 2 seconds. So the first line was MMM. What do we see in the input?
MMM SX.
Yeah, okay. So MM. Okay, so the first lines are all zeros. Yeah, okay, good. Yeah, looks plausible to me. Yeah.
Yeah, okay. Good. Okay, so then now that we have the map, so I think I want to basically create some sort of candidate positions. So one so I basically would want to create a list of positions. So that's my idea here. And the idea is that these are all the sequences in which the word Christmas or Xmas could appear within the grid, right? So these are basically supposed to be 4-letter or 4 consecutive characters or coordinates. And now let's see how we best generate these. So we could do this basically in some sort of star shape around an origin coordinate, right? So we basically give, let's say, candidates from, and we get one position as a starting point, and then we get a list of int, int, like this. And the idea would be that if we give a starting position, then we get sort of like from that starting position, if that is the starting position of the word, we get like 4 coordinates up, 4 coordinates to the top left, 4 coordinates to the left, right? I mean, diagonal and reverse was all possible. So I'm wondering now whether one can do that in a very, very elegant way. So probably yes. So we probably can do something like try to go from n like ij for 4 positions from a starting position in a particular direction. So so the
Why
idea
4?
Well, I mean, depends on how you count. Yeah, I guess. I mean, we want 4 results.
But
right?
why do we want 4 results? What are the 4 results, just so I understand? What are the 4?
Xmas has 4 letters, right?
Yes. Oh. Yeah, okay. But sorry, this is meant to give you all the coordinates.
Right, so the idea is that, I mean, like I want to get something like if I start from, let's say, 5, 3, if that's my starting position, then I want a list that contains sort of like starting here goes to 6, 3, 7, 3, 8, 3.
Yeah.
So that's basically in one direction.
So that's
but
to the
then
right.
That's one element of that. But then we would also go 5, 3, 4, 3.
Okay, so the first one is to the right, the next one is to the left.
Yeah, 2, 3, and then we get like 6 other directions, right?
Yeah. Okay, so 8 in total.
Yeah, but every one of these inner lists has 4 elements.
Yeah. Okay.
So I was thinking that I would compute one of those inner lists by saying having a function go from that takes an integer that basically tells us how many elements we still have to step. That takes a starting position. That takes a vector.
Right. Gotcha.
And it gives us one of those lists, one of those inner lists.
Yeah. Okay. Understood now.
And so here we could basically just I guess, is there like, I mean, I can just do it recursively. I mean, I would love to see some sort of even nicer way. Oh yeah, no, I think I do see a nicer way. I think I can probably just like if I have n, I can just create an infinite list. So I have like this x1, or let's call it I1, j1, I2, j2. So I want to create the list that starts with I1, j1, and then continues with I1. Oh, I don't have I cannot just create a sequence of this, right? Yeah.
You could use some parallel comprehension, perhaps?
No, I just want to create the enum. So I can, like, okay, I can do some like iterate. Iterate is a function. It's applies a function consecutively to an initial element. So iterate. So I can start from I1, J1. And the function that I want to apply is I want to basically pointwise add A2, J2. I have to define as well. So let's define this one as an int. Somebody will probably say I should be using, I don't know, bi-applicative or something like that for this.
No. I'm not so sure.
I'm not going to do that today. So just this, and then, yeah, so then I have this infinite list, and then I can just take n elements out of it. So let's just briefly check that I'm not building too much, which is just nonsense. So if we start from 0, 0, and we go 1, 0, that is giving me what I wanted. And so, for example, if I go from 5, 3, as I did up there, and I do -1, 0, I get the same positions that I had up there. So that is plausible. So then basically we want, well, now we need all the vectors. So basically let's call that directions, list of int. Directions is a list of ij's where I is going from -1 to 1, and j is going from -1 to 1, and I and j should not both be 0. Right? So let's double check what we've just written there. So directions is basically sort of the direction vectors that make sense. Like these are the 8 different directions that we could possibly go in. And then our candidates from should be a map over the directions. And so for every one of the directions, we want to go from 4 steps from ij. Actually, I don't even need to pattern match here. I can just do p in the direction. Okay, so let's double check this as well. Candidates from, stick with 5.3. That does look plausible to me. Okay, so now in order to do the candidates, I can just take, like, the candidates are, let's make the candidates dependent on the input, because we kind of need the size. And rather than just sort of checking the size, I guess I could just take the keys of the map. So if I have the input, I think keys is the thing that gives me a list of lists. It gives me a, sorry, it gives me a list of pairs of integers, I think. And then I want to compute the candidates from, I think I want to concat map candidates from over this. Okay. So now I don't want to print this because I guess this is going to be very large even for the sample input, right? So there are quite a few candidates. So now we have to check. So we can potentially be out of bounds, I think. So this is like one of the disadvantages here. So I mean, because we're only starting from positions that are in the map, but we can go outside of it. So we cannot assume that all the lookups we're doing are correct. So let's next write something like that checks a single candidate. So a single candidate is a list of int positions. And we want to, well, and we need the input. And we want a bool. So the idea is, or well, actually, let's do this in 2 steps again. So this is, I suppose, to check that, like, basically this position corresponds to the word Christmas, but let's actually write something like lookup candidate that takes an input and a list of int and gives me back a just,
a maybe,
sorry, a maybe string. And this should be traverse, I guess, or map m. So because we basically want to traverse, I think it's just traversing the input, the candidate, the path, let's call it path. And then for every one of these positions in the path, we want to do a map lookup of the position in the input.
Mm-hmm.
And that gives us a character, and so it nicely works out in this case that strings are lists of characters. So that just gives us a maybe string back. And then check candidate would be checking that a lookup candidate on input path is just and then we're getting close, I guess. Check input, or check in, let's call it check input, is input to int. That's actually what we need. That's
your part 1, isn't it?
That's part 1. Yeah, I'll just map part 1 to that. So that's just going to take all candidates for the input, and then we want to map.
Did you mean candidates, plural?
Yeah, I did mean candidate plural. Thank you. And then I want to map check candidate with the same input over this, and this is giving me a list of booleans. And then I want to check how many of these are true. Is that what's being asked? Yeah, I think it was the number of string. How many times does it appear? Yeah. So this is sort of the typical thing. If you want to check how many elements in a list are true, you can use filter ID to keep.
Why not just filter and then length?
Yeah, I was just going to think
length after filter.
Yeah, no, yeah, we don't need map and then filter ID. Yeah, so we don't can filter in the first place, and then thank you. Okay, great. I mean, the map and then filter ID would have worked, but it's it's a pattern that I would have hopefully spotted afterwards. But Haskell was a little bit quicker. Okay, so let's see. Let's try this on the sample first. Oh, I did not yet say that part 1 should be what did I call it? Check input, right? Um, 18. Okay, that's the sample. What did it say here? 18 times. That makes me hopeful. So now we should get our actual input. That's this. Save it to input.txt and call this on. By the way, also again, for people who have not been doing Advent of Code very often, these inputs are actually personalized, or, well, to some extent randomized. So not everybody is getting the same puzzle input. So we get 2,344 out. Let's see if that is right. Yay, okay. So we're not completely lost. That's good. But so now we get to part 2, and usually this is harder, so we'll see. Did you misunderstand the assignment? Looking for the instructions, you flip over the word search to find that this isn't actually an Xmas puzzle. It is an X-mas puzzle in which you're supposed to find 2 mas in the shape of an X. One way to achieve that is like this. Irrelevant characters have again been replaced with dot. Yeah, okay. Within the X, each mas can be written forwards or backwards. Here's an example from before. Okay, so this is not too bad, because I think we can take a similar approach. The candidates actually, to some extent, become simpler because the candidates are now just all X shapes. But then the check for a candidate becomes more complicated because, because of the potential reverse. Or is that actually true? Or if we generate the X shapes in, I guess we can afford to be slightly redundant. If we generate the X shapes in different orders, so basically, if we generate the X shapes so that we start in the upper left and go to the lower right, and then we start in the upper right and go to the lower left, but we also start in the upper left and go to the lower right and start in the lower left and go to the upper right and so on. So basically, if we generate all these different X shapes, then we should have all options, I think. And then let's see, we have 2 directions, 2 lines, 2 options. So that is 4 different X shapes per position, I would think, rather than 8 lines.
Yeah, I think so. Yeah.
So
that seems right to me.
So let's call that X's from, perhaps, rather than candidates from this time. X's from, X shapes from a starting position. And let me see about the X shape. So every X shape is 2 lines, right? So perhaps we actually want to use a pair of 2 lists of positions. Okay, so this is getting sort of in the realm where I should not use structural typing anymore, but I'm getting confused with all the different brackets myself already.
What's the purpose of keeping the SUSY lines sort of separate?
Because I want to,
as opposed to just this bunch of columns.
No, yeah, you're right. So so let me see. If I would put them in one line and concatenate them, could I just look for the string mass? I guess. Yeah, I could do one list that has 6 characters, and then look for the string mass. I don't think there is any potential for mistakes because the number is fixed, so that may keep the type slightly simpler. Is that what you meant? I'm not sure.
Yeah, something like that. Yeah, that's what I meant. Yeah, something along those lines.
I think I could
just to keep it. Yeah,
I could. Yeah, I think I could do that. That would keep the type the same. Yeah. Okay. So, and again, we can kind of use go from, but it's a little bit weird because we want sort of the X around something. So I guess, yeah, I'll not use reuse go from, I think. Oh, well, I can potentially do that. Let's just define minus as well. And let's say I'll do triple around a starting position. It's me basically starting position and the vector. So triple around, so this is my starting position, this is my direction. So I want to basically just have the point minus the vector, the point, and the point plus the vector. And
okay. So this is one of the two lines in the X.
That is one of the two lines in the X. Now I have to think about the sort of the pairs of the directions that are relevant, right? Because I only want the diagonal directions. So let's say diagonal directions. Those. So that's all I, j. I is from -1, 1. And j is from -1, 1. And I could have filtered from the directions list. That would potentially be slightly nicer for reuse, but okay. So that's the 4 diagonal directions. But now let's see. So how do we do this? So is this even useful, what I just did? Because I kind of need to do them in pairs. Is it better to just write them down, I guess? So direction pairs. Slightly too. So here I really want, I think, a list of pairs of directions. So I'm wondering whether, yeah, perhaps I mean, I'm certain I can generate them in some elegant way, but I'm wondering now whether it isn't like easier for me to just write down these 8 elements that I'm interested in. So if I go -1, -1, and then I go 1, -1. Oh no, but I can actually. Yeah. No, I think I can, yeah, I can take 2 directions, right? And the one direction is always coming from this list -1, -1, 1, 1. And the other direction is always coming from this list 1, -1, -1, 1. I think that's giving me, I think, the right direction pairs, and I don't need this one.
I'm not entirely sure where you're going, so I need to see an example exactly what you have in mind here.
The idea would be that my access from, I hope I can do that now, if I have my access from, would now always be, so I'm generating a list of, let me see, I want the direction pairs. I want all the direction pairs. And basically, for every pair of directions, I want to generate a triple around P. So map over the direction pairs. D1, D2. I want the triple around P, D1 and the triple around P, D2. Okay.
Do you mean plus here, or are you going to keep?
And then, yeah, and then because you said I can concatenate them, I can, I guess, just plus them. Yeah. Let me just do a plausibility check. Access from, let's say, what did we 5.3? So that gives us 6, 4, 5, 3, 4, 2. and 445362. That is already plausible to me. 645342 and 625344. Okay, yeah, I think that is actually fine. That is actually fine. Okay, and then now that I have the access from, I should basically be able to do the rest relatively similar. So the check candidate and check input, I'll just copy these two. Of course, one could also abstract. That would be nicer to sort of parameterize in the right way so that we can, but so we can reuse lookup candidate, I think. Perhaps I should have called that lookup path. So because this is, let's say, call that check X, and it's taking one such X-shaped path, and it's looking up that candidate, and it's now checking that this path, which has 6 letters, should be the string mass, and then check input prime, let's say, it's using check X. And it's also using access from rather than candidates. No, sorry, candidates is also something I have to redo. Because so that's all access. Access from an input is doing access from. I think that is plausible. So then this is check X.
Wait, candidates on 101. Candidates on 101 should not be candidates, right?
Candidates in 101 should not be candidates. Thank you. That should be access.
Access, yeah.
Okay, so let's try that on the sample first again. So it says 9. It said 9 here, so that makes me hopeful. And then we get 1815. Let's see.
Moment of truth.
Yay.
Hooray! Okay. Well done.
Very nice. Yeah, I mean, it's a nice task, I think. Obviously, there are a couple of things that could be done more beautifully, but I think sort of the general concept of generating the candidates and then checking them in the way that we did, I think I like that. I would probably just try to make it all a little bit more polished and try to see whether one can sort of like reduce the amount of duplication between the two parts a little bit more. But all in all, I think I'm reasonably happy with the solution. Were there
Can I make a comment?
Yeah, sure.
So there was a question quite early on, which is actually quite interesting because at the time that the question was asked, I thought, oh, this is outside the scope of this episode. Like, do you think 2-days array are a worse design decision than a list of lists? So if I can comment on this now, because this is quite interesting, because actually I did solve this puzzle prior to the episode. Like, Anders was completely new to it, but I solved it ahead of time. And my solution does not involve numbers anywhere. There's not a single number inside. It's all just list of lists. And so it kind of comes back to this question, right? So it very much depends. Like, arrays can be indexed fast. In this case, we're using map, logarithmic index. That would be fine. Arrays would have been fine here too, because we're generating these grids once and then we're indexing them all the time. So
yeah,
that would also
I think arrays would certainly be fine here.
Yeah. I just don't like arithmetic. I don't like thinking about numbers. So I have a completely different solution, which works with lists and does all very listy things. Like it takes transposes, it takes tails, it takes all these kinds of things. And there we're constructing new lists all the time, right? Like we're taking sublists, we're taking submatrices, we're turning the things around. And then it makes much more sense to use list of lists rather than arrays because we're doing construction all the time. So I don't know if it's worth talking about my solution at all, or
No,
I can post it, but
yeah, I think it would be nice if we include your solution in the repository as well. I think, I mean, I briefly thought about approaching this in a different, I briefly thought about a list of lists as well, because that is the format you kind of get it, like when you just, right? I mean, we are having kind of a list of lists here at this point. so it's an intermediate data structure anyway. So I guess I'm not exactly sure. I was slightly worried about, in particular, sort of the diagonals, and the one could kind of shift the entire. I think that is the approach that I would probably then do.
So there's also the question in the chat at the moment.
If I do a list of lists, I would probably try to shift the entire grid, one to the right and another to the right, and then do some sort of overlay.
I can very briefly show what I have done.
But yeah, I would also be interested in whether there were any other questions, though.
There aren't. No.
Okay.
Not really.
Okay. All right. No. Yeah. I mean, if you.
I mean, we don't have to. I can just. I just thought it was interesting because there was this question about arrays in the very beginning, and then you went a completely different route to me. So
yeah, I think that is one of the beautiful things that also, like, of course, if you so something that I haven't done today, like deliberately, but if you're checking the sort of Reddit threads that there are every day on sort of these advent of code problems, then you'll find lots of people posting their solutions there, and you see that there are lots of different approaches being taken. And obviously, I mean, some people manage to solve these problems in just 3 lines of code, or using entirely exotic approaches. And often people are also just using the opportunity to learn a new programming language. But I think it's I
would say about your approach is that the same approach worked really very well between the two halves, whereas my solution doesn't have much in common between the two halves. So that's a one downside of it. I don't know. What do you want?
It's also something I would have been more worried about, like if I had chosen a list of lists approach. I mean, like given sort of the past experience with advent of code problems, I would have been more worried about that the second part is just making that completely infeasible. I was actually kind of worried that we would suddenly have to do complicated updates on the array or something like that.
Right. I see. That's why you went for the map.
That's why I went for the map and not the vector. But there are these kind of things. But as I said before, you're sometimes tricked into like having sort of the wrong idea about what the second part might be, and like certainly, I mean, I would advise not to overcomplicate. Like if there's a decision between one approach which is vastly more complicated in the first place, just because you believe something might be needed to generalize later, then don't do it. But if there is a choice between 2 roughly equally complicated approaches, then take the one that keeps more flexibility. But I mean, this is sort of like a problem-solving strategy advice for advent of code, not necessarily transferable to other situations in life. But yeah, okay. We.
So do you want to show the diagonals, or will I just post the other solution?
I'm not. Yeah, I mean, well, I mean, sure. If you have it ready, you can.
I have it. Yeah, Since there's a question, how do you do the diagonal? So this is so the original. So this is a matrix I just have as a list of lists, right? So how do we check all the horizontal words? Well, we just look them up in this guy. Then for the vertical words, we just take a transpose, right? And then the tricky thing is the diagonals. And the diagonals actually is quite simple. What we do is you take the original part of the matrix, you drop 0 from the first one, then 1 from the one, 2 from the next. So you get sort of the triangle, and then you take a transpose of that, and that gets you the upper half of the diagonals. And then on the bottom half, you take those things instead. So you take 0 from the first line, and then 1 from the next one, 1 from the next one, and then you reverse them so that they shift, and then you transpose again, right? And so that's your diagonals. And then, of course, the diagonals in the other direction, you just reverse, and that's it. And then all of my code, like this is it, is, it's 100 lines of code, whereas this could have been written a little bit smaller, but these are the different X's, which I just chose to write out rather than try to be clever about it. So there's no index manipulation there, but I mean, these are just alternative approaches. We'll post both, and then you can compare and contrast and ask questions. But I did take a lot longer than Andres, so I'm impressed. Well done.
Well, I mean, I think, it was probably the longest I took so far this year, but it's also a different situation when you try to explain it to someone as you're going. I mean, I'm usually solving these for myself.
Sure, of course.
And it is certainly a lot of just getting used to the pattern of these problems, right? You're not usually solving.
Yeah, I've never done this before. So
yeah, exactly. Yeah, okay. I think you do the outro.
Okay. I'm very good with the back and forth. So thanks, Andres. Well done. Thanks everybody for watching. This is going to be the last episode of the year. We'll be back in the new year with some new developers in GHG as our first episode, probably, but we'll see. We will post that in the usual places. For now, if you liked it, please like and subscribe, and we'll leave the chat open for a few more minutes if people have any questions. And always feel free to leave comments below the video, and we'll try to in the comments, and we'll always try to answer them. Thanks very much.
Thank you.